weight is the gravitational force acting on a body. Yes, my friends, I am here in this seat because the gravity pushed me down. Without the gravity, everything floats. The gravity is a centripetal force that keeps all the elements, all the objects against the ground. How much is the value of the gravity? It's 9.81 meters per square seconds. Alright, what is the formula for weight? Weight is equal to the external force. According with the second law of Newton, force is equal mass times acceleration. In this particular case, is the acceleration of the gravity. This is the second law of Mr. Newton. What states the second law of Mr. Newton? This Newton's second law details the relationship between the force, the mass, and the acceleration. If you push or pull an object in a particular direction, the object accelerates in that direction. It's simple. This is the second law of Newton. And this is the law that keep in movement all the objects on the environment. Now we are going to introduce one important concept, is the concept of work. Work in order to understand power. And after that we are going to try to understand what is the meaning of torque and what is the difference between work and torque. Let me explain something. What is the formula for work? Work is the force applied in an object during a distance. Is force times distance. And the unit is a Newton meter. Newton per meter. Or Joule. The other name for Newton meter is Joule. This is work. This is work. Work is force times distance. And is the force that you apply. This is an object. This is the ground. And this is the force that you apply on the object in order to move the object some distance. And the work is equal to the force applied times the distance. It's simple. The work is linear. What about torque? Torque is the force that you apply to twist it a bar. For example, this is the front view of a rod of iron. If you apply a force here, and this is the radius, the torque is equal to the force times the radius. The force times the radius. What is the unit of a torque? It's exactly the same. It's Newton per meter or Joule. Those are the units for torque. In other words, work and torque are basically the same. Work is the force applied to an object, linear, and torque is the force applied on the object in order to twist it. Torque is angular and work is linear. That's the only difference. Torque is angular because it's force times radius, and work is linear because it's force times distance. That's the only difference. We have an example here for a torque. We are going to apply a force of 5 newtons, and the distance in between the center and the end is 40 centimeters. How much is 40 centimeters in meters? Is equal to 0.4 meters. Okay, what is the torque applied over there? The torque is basically the force, 5 newtons, times the distance, 0.4, and this is 2 newton meters. 2 newton meters is the torque applied on that object. This is an example in order to calculate the torque. Don't forget, work is linear, and torque is angular. In electricity, you remember, according with the Ohm law, we have the formula for voltage. Voltage is equal to the intensity times resistance. And what is the formula for power? Power is equal to the voltage times the intensity. And what is the unit for power in electricity? Watts. 1 kilowatt is equivalent to 1,000 watts. Alright, this is in electrical systems. Okay, Mr. Newton, in mechanical systems, state that the force is equal the mass times the acceleration. And the power is the work in a period of time. This is power. This is the formula for power in mechanical system, and this is the formula for power in electrical system. It's possible that I convert mechanical power into electrical power, or vice versa, electrical power into mechanical power? Yes, it's possible. There is a magic formula to convert mechanical power into electrical or electrical into mechanical. What is the unit of the mechanical power? The unit is horsepower. And what is the unit for the electrical power? Watts. And the formula says that 1 horsepower is equivalent to 746 watts. Is equivalent to 746 watts. This is an important formula. In the future, we are going to use that formula to calculate the capacity of the engine. Suppose that you have a generator, the generator is damaged, and you want to use the engine of the generator, because the back end, the electrical portion of the generator, is in good condition, and you need to replace only the engine. But you don't know how much horsepower you need on the engine in order to replace the engine for a new engine. With that magic formula, you can calculate that formula. Is pretty simple. Suppose that you have a generator. This is an example. You have a generator of 20 kilowatts. And the engine, this is the engine. The engine is broken. The back end is in perfect conditions, but the engine is broken. And you need to know how much is the horsepower, the minimum horsepower that you need in order to replace that engine for other one in order to supply 20 kilowatts. Okay, you know that 1 horsepower is equivalent to 746 watts. Okay, right now I have 20,000 watts. How much horsepower are? This is the question. Okay, is 20,000 divided by 746, and this is the amount of a horsepower that you need to replace the engine. And now we are going to introduce other important formula, the torque. Because depending on the amount of torque produced for the engine, you can produce on the propeller of the boat more thrust or less thrust. It's with the torque that we are going to do the majority of our calculation, not with the horsepower. Be careful with that, because probably you don't need more horsepower in the engine of your boat. You need more torque. That's different. It's a different concept. The torque produces for an engine. This is an example. This is the diagram of the dyno, the dynamometer. The dynamometer. The dynamometer is too simple. This is the shaft. This is the shaft of the crankshaft. This is the crankshaft here. And you install these mechanisms. These mechanisms have a friction material here. Friction material here, like the friction material that you have in the pads of your brakes. And here you have an scale. And now, depending on the pressure that you apply here in this bolt, and depending on the RPMs of the crankshaft, you can produce here a vertical force. And the vertical force times the radius produce the torque. And this is the magic formula that we are going to use in the future in order to convert torque into horsepower. It's easy. The formula states that the torque should be equal to the horsepower of the engine, times the constant 52, and divided by the engine RPMs. Alright, my friend, this is an important formula. If you check that formula, the formula states that the torque is equal to the horsepower times the constant and divided by the engine RPMs. At what RPMs? Idle or middle or wide open throttle, full RPMs, the engine produces maximum torque. What do you think? The engine produces more torque in idle or more torque in wide open throttle? Let me check. In general, how much is the acceleration in RPMs when in a diesel engine, inboard diesel engine, marine diesel engine? What is the maximum amount of RPMs in a typical inboard marine diesel engines? Are in between 2200 and 2500 RPMs. This is the maximum RPMs in a typical inboard diesel engine. And what is the idle? The RPMs in idle normally is around 900 RPMs. Right? Don't forget, keep in mind that number is very important. Alright, we are going to calculate the torque in wide open throttle. Suppose that we have an engine with a motor of 200 horsepower. 200 horsepower, this is the power of the engine. Okay, we are going to calculate the torque in wide open throttle. Is 200 times 52 and divided by the RPMs in wide open throttle. How much are the maximum RPMs? The maximum RPMs are, for example, 2200. How much is the torque in that point? Is 200 times 52 and divided by 2200. This is 477.45 Newton meter. Alright, how much is the torque? How much is the torque in idle? The torque in idle is 200 times 52 divided by the RPMs in idle, 900. How much is the torque over there? is 200 times 52 and divided by 900, and is 1167.11. Alright, what torque is bigger? This one is bigger, the torque in idle. Yes, my friends, less RPMs produce more torque. High RPMs produce less torque. How is the curve of the torque? We are going to do the graphic, and this is the torque, and this is the time, or the RPMs, and this is idle. This is 1500 RPMs, and this is 2500 RPMs, and normally the curve is like this. And yes, the maximum torque is produced in idle. And normally the majority of the manufacturers, they recommend, this is the operational RPMs. The majority of the boats recommend accelerate the engine in between 1400 and 1800 RPMs. This is the operational template. This is the formula. Torque is equal 52 times the horsepower and divided by the engine RPMs. Don't forget, 52 is a constant. Okay, now we are going to calculate. The first operation is to calculate the piston displacement. How much is the amount of air that the piston suction in one complete movement if the intake valve is open? How many air can introduce the piston when the piston is going down? We are going to calculate the piston displacement. In order to understand easily piston displacement, we are going to refresh our concept of geometry, and we are going to refresh how to calculate the value of a cylinder. The value of a cylinder is basically the base area times the height. Is the base area times the height. Okay, in our particular case, the base area is the area of the piston head, and the height is the stroke. How much is the area of the head of the piston? Okay, the area of the head of the piston is pi times the radius square and times the height. The height is the stroke. This is piston displacement. This is piston displacement. Alright, I want to put the area of the head of the piston in terms of the diameter, not in terms of the radius. Okay, I am going to replace the radius for the diameter divided by 2. Okay, this is equal to pi times the diameter divided by 2 square times the stroke. This is the piston displacement. What is the other name for the diameter of the cylinder? Is the bore. Okay, I am going to replace pi times the bore square divided by 4 times the stroke, and this is piston displacement. Very, very simple. Alright, it's pi times bore square divided by 4 and times the stroke. This is a simple formula, and this is the value of air in one cylinder when the piston is going down. And what is the engine displacement? Engine displacement is the value of air in one cylinder times the number of cylinders. For example, I have a V8 engine. The engine displacement is equal to the piston displacement times A. Okay, in this particular case is pi times the bore square divided by 4 times the stroke and times A, because it's a V8 engine. This is the engine displacement. I have an example. You have this example in your book. We are going to calculate the engine displacement for the typical 427 V8 Chevy. And we have some measurements. We know the bore is 4.312 inches, and we know the stroke is 3.65, and we are going to calculate the engine displacement. Alright, in this particular case, we are going to calculate the engine displacement for a V8 engine. We know the bore, we know the stroke, and the formula says that the engine displacement is equal to pi times the bore square divided by 4 times the stroke and times the number of cylinders. In this example, the engine displacement is 426.3, and you can approximate to 427, and this is the famous 427 cubic inches. Yeah, this is a very common procedure to calculate the engine displacement. If you know the bore, if you know the stroke, and you want to know the amount of air in total that the engine can suction when the pistons are going down. We are going to solve an example. Suppose that we have the famous Chevy 350. Okay, is the engine displacement is 350 cubic inches, and suppose that the bore for that engine is for example 4.2 inches, and the question is how much is the stroke, how much is the distance that the piston travel from the bottom to the top. Okay, we are going to use the formula engine displacement is equal to pi times the bore square divided by 4 times the stroke and times the number of cylinders. Okay, in this particular case the engine displacement is 350, and is equal to pi 3.1416 times the bore is 4.2 square, 4.2 square divided by 4, and times the stroke, this is the question, and times the number of cylinders, 8 cylinders. Okay, in this particular case the stroke is equal to 350 times 4 and divided by pi 3.1416 times 4.2 square and times A. This is the value of the stroke in inches. Simple. This is the formula to calculate the stroke. Yeah, we can use this formula to calculate the bore, to calculate the stroke, or to calculate the engine displacement. We are going to talk about the compression ratio. What is the meaning of the compression ratio? When you buy a car, you see on the catalog, in the catalog they say, oh, the compression ratio of this car is 10 to 1, but the other model is 11 to 1. Or, what is the meaning of that? And what happens if the compression ratio is higher? My car is better? Or what happens if the compression ratio is lower? I have less efficient or more efficient? What is the meaning of that? Okay, we are going to try to understand what is the meaning of compression ratio. But it's very simple. You remember when the piston is in top dead center? You remember that small value? What is the name of that value? It's the volume of the combustion chamber. Okay, and you remember what happened when the piston is in the bottom dead center? Yeah, this is the total value of the cylinder, no? And this is the value only of the combustion chamber. Compression ratio is, let me check if I can introduce that small value of the combustion chamber in the total 1, 2, 3, 4, 5, 6, 7, 8. The compression ratio of this engine is 8 to 1. That's clear? Is the value of the combustion chamber how many times you can divide the total into the volume of the combustion chamber. This is the definition of compression ratio. The simple formula for compression ratio is this. The simple formula for compression ratio is this. Is the value of the piston displacement plus combustion chamber divided by the value of the combustion chamber. Simple. Yeah? The piston displacement plus combustion chamber divided by the combustion chamber. This is the compression ratio. Simple. In diesel engines, calculate the value of the combustion chamber is too simple. Because if you have the piston that you have on the screen right now, you can fill that pocket with water, and you can calculate in a special jar with the division in ohms or milliliters how much is the value of the combustion chamber. And you know the value of the combustion chamber, and additionally you know the piston displacement when the piston goes down. Okay, and now you can calculate how many times you can introduce that volume in the total length, and this is compression ratio. There is volumetric efficiency. Right now, with this formula, with the formula of the engine displacement, we calculate in theory how much is the amount of air that my engine suction when the pistons are going down. 5 liters or 4.7, according to the formula. But this is the ideal. How much is the real amount of air enter in the combustion chamber in this moment when the pistons are going down with the intake valves open? It's not 4 liters, it's 3.83. Let me check that. If you have this slide, we are going to talk about volumetric efficiency. Volumetric efficiency. What is the meaning of volumetric efficiency? Is the actual volume of air divided by the theoretical volume of air. In other words, the volumetric efficiency is the real engine displacement divided by the theoretical engine displacement. The theoretical engine displacement of this engine is 5 liters. But really, today, only I have 4.7. The volumetric efficiency is 4.7 divided by 5 times 100. This is the volumetric efficiency. Finito. This is volumetric efficiency. Yeah. Why the actual amount of air that the piston suction when the piston goes down is a little less than the theoretical? Because you have leaks, because your engine is 200,000 miles, because the valves don't close properly, because you have a small leak in between the head and the block on the head gasket, because there are too much leaks, because there are dissipation of heat. In general, the real value is not exactly the same like the theoretical. Normally it's less. Yeah, for that reason the efficiency is impossible. 100% of efficiency. Probably in the moment that the engine is new at the sea level, probably is 100. But with a couple of miles running, the efficiency goes down. This is volumetric efficiency. Okay, guys, in order to understand the forex trucks, I prepared this slide. This slide is this is the block. This is the block. This is the head. The piston is moving up and down, and the crankshaft is rotating. In this particular example, we are going to suppose that it's rotating clockwise. All right, and those are the intake valves, and those are the exhaust valves. And I prepared this table. In the table, I put the typical 4 strokes that you hear: intake, compression, power, and exhaust. Intake, compression, power, and exhaust. Those are the typical 4 strokes. And we are going to understand what is the meaning of that. What is the meaning of intake, compression, power, and exhaust? All right. I need that you follow me, and at the same time follow the table that we are going to fill in order to understand what is the meaning of 4 strokes. And after that, with the same concept, I am going to explain what is the meaning of 2 strokes for gas and diesel. All right, my friends. Suppose that this is the head. This is the head. My hand is the head, and this is the piston. And in the head, I have 2 valves. I have intake valves and exhaust valves here. Intake valves and exhaust valves. Those valves that you have here on the screen, intake and exhaust. And this is the piston. All right, suppose that I am going to start with the intake. When the piston is going down. Okay, let me check. In the intake, the piston is going down. Ready? Perfect. The piston is going down. Now, when the piston is going down, I want to enter air in the diesel engine or air and fuel in the gas engine. Ready? Okay. In that case, when during the intake stroke, the piston is going down, and what valve is open? Intake valve or exhaust valve? Intake valve is open and exhaust is closed. Okay. During the intake valve is open and the exhaust valve is closed. Perfect. And the piston is going down. And the crankshaft, in this movement, the crankshaft rotates half turn. The crankshaft rotates 180 degrees, half turn. All right, perfect. And now the piston is in the bottom. And the piston starts to go up to produce compression. What happened with the valves in order to compress? Should be both of them closed. Okay. Close and close in compression. The piston is going up. The piston is going up. And the crankshaft rotates other 180 degrees. Other 180 up. Right now, the piston is at the end, on top that center when both valves are closed. And the piston on top. Ready? And now the fuel enter in diesel engines and produce the explosion, or the spark plug produce the spark and ignite the mixture. Okay, in this moment, the power is produced, the explosion is produced, and the piston goes down. What happened with the valves? The valves open or close? The valves continue closed, but the explosion is produced. Okay, in power, the piston goes down again. The explosion sends the piston down. Other half rotation of the crankshaft. Other half rotation of the crankshaft. And the piston, the valves close and close. And now the piston is in the bottom again, and all of this cylinder full of smoke. And right now the piston try to goes up again, and what happened with the valves? Intake and exhaust. Intake stay closed and exhaust open, and the smoke goes out. This is exhaust. All right, the piston is going up. The crankshaft rotate other 180, and the valves intake closed and exhaust open. Bingo. In 2-stroke engines, when the piston is going down, occur intake and exhaust at the same time. And when the piston is going up, occur power and exhaust, power and compression. Yeah, 2 strokes in each movement. For that reason, the name of that process is 2-stroke engines. All right now I am going to explain quickly what is the main difference between both type of engines. But in order to understand easily the 2-stroke gasoline and 4 strokes, let me explain something about that. If you remember, in a 4-stroke gasoline engine, we have the head, and in each side of the head you have a exhaust manifold and intake manifold. This is the intake manifold. And on the intake manifold, you have the throttle body or carburetor, and on top you have the air filter. That's the air filter. This is for 4-stroke gasoline engines, or diesel is similar. All right. for two strokes, and remember, in 4-stroke you have the valves located on the head, the intake and the exhaust valves located on the head, and the camshaft is connected with the crankshaft by means of the timing chain. Right? This is in 4 strokes. In 2 strokes, what happened in 2 strokes? In 2 strokes, there are some difference. For example, in 2 strokes, the cylinder is not a cylindrical element like this. The cylinder have a couple of holes, one in each side, 2 holes, one in front of the other one, like the picture that you have on the screen right now. In the bottom of the cylinder, if you check in the picture, there are 2 holes, one practically in front of the other one. And additionally, the shape of the piston, the head of the piston in 2-stroke engines have this shape, like a castle, like this. And what is the idea? In the bottom of the cylinder, there are the holes, one hole here and other hole in the other side for exhaust, because the exhaust manifold is located here in the other side for exhaust. Yeah, one of the difference, if you check for visual inspection, the 2-stroke engines have the input of the mixture and the output of the gases in the bottom of the block, not on top. In a 4-stroke engines, the intake and the exhaust manifolds are located on the head, in each side of the head, like the picture that you have on the screen right now. This is in 4-stroke. In 2-stroke is in the bottom of the block, because in this particular case, this is the intake manifold. And in the intake manifold you have here the carburetor or throttle body, and the carburetor mixed the fuel and mixed the oil and mixed the air. You have fuel plus oil plus air entering in the combustion chamber in the bottom. Yeah, for one side of the holes. In the other side you have the exhaust. Let me show to you. This is the situation, exactly the situation. This is the block, and this is the head. The head only have the hole for the spark plug. Yeah, and on the cylinder you have one hole here for intake, and you have other hole here for exhaust. Let me check what happened. And in the bottom, in the crankcase, when you talk about the 2-cycle cylinders or 2-stroke engines, the name of the oil pump is the crankcase. The crankcase and the block, this is the bottom of the engine. In the bottom of the engine, in the crankcase, this is the crankcase. In the bottom of the crankcase is where the oil pan is together with the block. There are one port with a valve, like a check valve. That port allow, this is the carburetor with the air filter, with the fuel tank, and other tank here for oil. All right, this element, this carburetor mixed the fuel, the oil, and the air, and in the crankcase enter all of those elements: fuel, air, and oil. And when in between the cylinder wall and the piston, the mixture goes up. Here and enter in the combustion chamber when the piston reaches the bottom, and this hole is in front of the other hole. In other words, in that moment when the piston is in the bottom dead center, BDC, in the bottom, the fresh mixture enter here with high pressure and push the smoke out, and the smoke goes out. The name of that process is scavenging. What is the meaning of scavenging? Is the cleaning of the combustion chamber when the piston reaches the bottom depth center, and the fresh mixture enters for one port and pushes the smoke in the other port. This is the scavenging and occurs in two-stroke engines.